everyone. So we're going to be doing station number 1, which is on page 6 of your packet. You should have already played around this with the PhET simulation, but now we're going to do it with actual circuit equipment. So first we're going to set our battery eliminator to 3 volts since we're working with a 3-volt battery. Then we need some way for the electrons in this circuit, right, to make it to our light bulb, to make it light or make it not light. So I'm going to connect one of this black wire and this red wire to the 2 outputs of our battery eliminator. I have these 2 alligator clips. I'm going to connect the light bulb to 1, and now I'm going to turn my voltage on. So it doesn't light, right? Because there's no way for those electrons to make it, it's not going to go through the light bulb because there's not a closed loop. That's what's important about a circuit. It must be a closed loop. But if I connect to the other side of the light bulb, I do see the light bulb light up. So basically you need a full closed loop to make the light bulb light, and I'm going to show you what this looks like. So we have the 2 wires coming out of the battery eliminator. One wire goes to the light bulb, the other wire goes to the other side of the light bulb, and that's what creates a closed conductive loop. Okay, so the next part was to make a light bulb light with 6 volts and to observe what happens to the brightness of the bulb. So I'm going to turn our voltmeter, or battery eliminator, up to 6 volts. So you can tell that this is a lot brighter. You see a lot more light coming from the bulb than if it was at 3 volts. Now it's at 6 volts, and this is much brighter. So more voltage in general for a light bulb is going to mean more brightness. And then the next task is to try to make 2 light bulbs light. So I'm going to need to add another light bulb into my circuit. So I'm going to connect my red wire from my circuit, so this is the one that's connected to the red output, to the 1 light bulb. So now I have my black wire still connected to my light bulb, and I have my red wire now connected to a new light bulb. So I need to provide a closed loop, and so I'm going to connect this black wire to the 2 light bulbs. So now my circuit, and I'll show you in just a second. Now my circuit goes from the battery eliminator to the light bulb. Then it goes through this black wire and goes to this light bulb right here, then goes to the red wire and flows back to my circuit. So it's a full closed loop. Okay, now let's see what happens to the 2 light bulbs. There's the 2 light bulbs. When I turn the battery eliminator on. Okay. So you can see the 2 light bulbs, and they both go on. So there's one, there's the other. They both go on, and they look like they're pretty equal brightness. Okay, so that's one way, and that's just really just adding another light bulb in the path of your circuit. So you're making just a longer path. The other way to add another light bulb into your circuit is to add it in what we call parallel. So initially I had my circuit that looked a little bit like this, and so I had my black wire, my red wire, and instead of adding my light bulb, just breaking that path and adding another light bulb in, I'm going to create another path for electrons to flow. So they come from the negative end of the battery eliminator, so this black wire. And then instead of all of those electrons flowing through this guy, I'm going to have some flow through this one. So this is another way that you can do this. And then basically you need to create another closed loop for this light bulb, but it needs to end where the other light bulb ends. So now what I have is I have this circuit. So I have my two pathways. I turn on and both are very, very, very bright. So this makes your two light bulbs very bright. They're still equal brightness, but they're very bright. And that's it. So what determines whether current will run through a circuit is if it's a closed loop. And then what happens to the brightness of the bulb if more resistance is added to the circuit. So that brightness of the bulb is going to decrease. So when we added that second light bulb, when we disconnected the path, so we notice like this is what the brightness looks like right now. If we disconnect that path and just add another light bulb in the pathway of our single path of my circuit, then that brightness is going to decrease. And that's station 1.